Calculate the volume of 0.5 mol per dm cube tetrazosulfate 6 acid that is neutralized by 25 centimeter cube of 0.1 mol per dm cube sodium hydroxide, that is NaOH. Solution. From the question above, it can be concluded that we are dealing with a neutralization reaction, which is the reaction between an acid and a base to give salt and water. So the first thing to do here is to write out the chemical equation. So we'll start with the acid, which is tetrazosulfate 6 acid, that is H2SO4. Reacting with the base, sodium hydroxide, so give the salt we'll be having here is sodium sulfate, so we have Na2SO4 and water. So after writing the chemical equation, the next thing to do is to balance the equation. So to begin with the base, we have one atom of sodium present here, and in the product side we have 2. So to balance that, we'll be adding 2 here as well. So this make it 2. So we have 2 atoms of sodium present on both sides. For the oxygen now, this 2 is also affecting every other element present in this compound. So we have 2 atoms of oxygen present here plus 4 here, which makes it 6. On the product side, we have 4 plus 1 here, that's 5. So this also needs to be 6. So to do that, we have 4, it remains 2. So let's add 2 here. So 2 times 1, we have 2. So we have 2 atoms of oxygen present here plus 4, that's 6. So and in the reactant side, we have 6 as well. So oxygen is balanced. For hydrogen, we have 2 here plus 2 in the acid, that makes it 4. So in the product side, we have 2 times 2, that makes it 4 as well. So let's check for sulfur. Sulfur here we have 1, and in the product side we have 1. So if we check for every other element, then we can see the equation is balanced. After writing out a balanced chemical equation in any calculations involving neutralization reaction, the formula we'll be using is CAVA divided by CBVB, which is equal to Na over Nb, where Ca is the concentration of the acid, Va is the volume of the acid, Cb is the concentration of the base, Vb is the volume of the base, while Na and Nb are the number of moles of the acid and the base respectively, which is usually gotten from a balanced chemical equation. Let's proceed. We're writing out the formula we'll be using. The next thing to do now is to write out the values given from the question. So let's begin with the acid, Ca. From the question, we have Ca to be 0.5 mol per dm cube. Then Va is given to be unknown. Yes, because the question says calculate the volume of 0.5 mol per dm cube H2SO4. That is, we have been asked to calculate the volume of the acid. So we have Va to be unknown. Then Na, that's the coefficient of the acid. The coefficient here is 1. So for the base, Cb equals 0.1 mol per dm cube. Vb is given to be 25 centimeter cube. And Nb, which will be gotten from the balanced chemical equation, that is the coefficient of the base. So the coefficient here is 2. So we have Nb to be 2. Now after writing out the values, the next thing to do is to calculate the unknown. The unknown here is Va, that is the volume of the acid. So to get that, we'll simply make Va the subject of the formula by cross multiplying. So we say Va equals CbVb times Na divided by Ca multiplied by Nb. So let's substitute the values. We have Cb to be 0.1 mole per dm cube multiplied by Vb, which is 25 centimeter cube, multiplied by Na, which is 1, divided by Ca is given to be 0.5 mole per dm cube. And Nb, which is 2. So this gives us 2.5 over 1 and the unit centimeter cube, which is equal to 2.5 centimeter cube. So we've gotten the volume of the acid used to be 2.5 centimeter cube. So with what we did just now, it can be concluded that the volume of 0.5 mole per dm cube tetrazosulfate acid that will be neutralized by 25 centimeter cube of 0.1 mole per dm cube sodium hydroxide is 2.5 centimeter cube. That is 2.5 centimeter cube of tetrazosulfate acid will be required, and that answers the question.